Okay, so chapter 7 is talking about continuous probability distribution. Okay, you know that previously you have covered the basic probability, and then the chapter 6 you covers discrete probability, and now this is the last probability, what we call continuous. And at this stage, I'm assuming that you should know the difference between discrete and continuous. So whenever you talk about discrete probability, the example is always the result of counting, right? You can count 1% and so on. Continuous, of course, the example, the question that is given to you will be in continuous variables, and the number will be in a decimal point. Okay, so what do we have under continuous probability? Okay, so there are three things as well. In your discrete, you have what we call binomial, hypergeometric, and Poisson. Now we also have three things, but we only cover the second point. So please ignore uniform distribution and exponential probability distribution. We will not cover this in your syllabus. We will only cover normal probability distribution. So under the normal, we'll look at all these points. Okay? So that's why you can see some of the slide has been crossed because we don't want to look at them. Okay? Okay, now we'll start with the normal probability distribution. So what is normal probability distribution? Okay, basically this is just your normal, well, distribution, right? The name is normal. So this is just like your bell curve. Okay, so the middle is actually equals to 0. Okay, so you're going to have negative infinity, you're going to have positive infinity. Infinity means that the number keep increasing. We are talking about a large number. Okay, so remember, in total, your probability, or we can say that the area under this curve is equals to 1. Okay, so the left side of the diagram is 0.5. Another right side is 0.5. That's why when you sum these two, you will get equals to 1. So normal probability is actually what we call a symmetric distribution. Symmetric means they have a mirror image. The left and the rights are equally the same. Okay, and how you want to explain your distribution, okay, or your shape, the bell curve shape. So you can explain your distribution using mu as well as standard deviation. Okay, what we call sigma. And of course, if you talk about your normal probability distribution, you have one peak in at the middle. Okay, okay. So that is the characteristic of your normal probability distribution. Okay, so I have explained to you how does it look like, right? So your mu, your mean, mediums, and modes are all equals, and they are in the middle. Okay. So this slide is just telling you that you're gonna have a different shape of distribution. Okay, so if you look at the diagrams number 3, if you can see the number, okay, you have, let me make it bigger, okay, so that you can see it clearly. Okay, you have blue color, green, and red. So, well, they are all looking different, right? Why is that? Their shape are different. When their shape are different, it means that they have different variance. If you look at the blue one, the variance or the standard deviation is actually 41. Okay, okay. While if you look at the green one, it's a bit flatter. So the standard deviation or the variance are larger. So you don't want to have a high standard deviation, because standard deviation means that you are making error. So you don't want to have more error. Well, if you look at the red one, even though it doesn't look good, but because it is very narrow, so basically you can see the standard deviation, the sigma, is 26, is smaller. So you want something which has lower standard deviation. Okay? So look at the next graph. Okay, I label it as number 2. You can see that the shape are all the same. What does it mean? Remember, the shape tells the variance or the standard deviation. So it says that the standard deviations are all the same. The only difference is that they have different mu. The first green color, the mu is 200 something. And the second, it has 300 and so on. Okay, sometimes the shape may look the same because they have the same variance or standard deviation, but their mean could be different. Okay, so I just want to tell you that the normal probability distribution has different shape and different mean. Okay, so this is the key formula in this chapter. What is this? You have to remember this formula by heart. Okay, so the formula is Z equals to X minus mu over standard deviation. Okay, so you need to apply the formula of Z in order for you to find the probability. Okay, so let's look at the next slide. Well, this is just the example. Okay, so let's look at the real example. What is it? Okay, there are a long question. I will just go straight away to the question. To the main point. Okay, but if you have received your question in the quiz or midterms or final, please read the whole thing. Okay, so suppose the weekly income of Uber driver follow the normal distribution. Why does it say it's normal? Because you will remember when we talk about normal probability distribution, your graph will look like normal. Okay, the one that I drawn to you just now. With the mean. Okay, this is a probability question. Remember when we talk about probability, the first thing you have to do is list down all the information. Okay, so what is the mean? The mu equals to 1000. Next, standard deviation. Okay, standard deviation is actually in the form of sigma. Sigma is equals to 100. Okay, now what is the question? Okay, what is the Z value of income for a driver who earned 1100? Remember, this is just like your previous probability. How you want to find the X? X will be given in the question. So your X equals to 1100. Okay, can you find the Z value? Of course, you have the formula here. So how to find it? So the X, so Z equals to your X, which is 1100 minus your mu 1000 over sigma, which is 100. Then you will find the Z value equals to 1.00. You can say 1, it's fine, but normally in probability, we want to have some decimal point, right? So you can put 2 or basically we will take 4. Okay, 2 is fine. Just to compute the Z value. Okay, so this is just to answer the question of find the Z value. But if let's say the question asks you, what is the probability of income for a driver who earns 1100? Probability. If let's say the question asks you to find the probability, so basically you have to convert this Z value into the probability table. So how to find the probability? Go to your statistical table. Okay, so there are so many tables in your statistical table. So how would you know which one is the Z table? Of course, the name of the Z table is area under the normal curve. Just to let you know, okay, this area under your normal curve, this is your curve, right? Normal curve. So the area under the normal curve is called as probability, or what we call likelihood, or chances. Remember, probability is just the chance of something to happen. So the area under your normal curve is your probability. So now you already know that your Z equals to 1.00. Okay, make sure that you shouldn't look at this value. This is 0.1. No, yours is actually 1.0. 1.00 is this one. So the value is 0.3413. Okay, so your probability is 0.3413. So this is your probability. Okay, so just to let you know, normally in the question, they will not ask you find the Z value. Never. They will ask you to find the probability. Okay, that's why I straight away telling you how to find the probability. Next. Okay, this is another thing about empirical rule. Remember you have seen empirical rule in chapter 3? Okay, so empirical rule, they have 3 values, right? You have, okay, let me write it here. For empirical rule, we are talking about normal distribution. In the middle is equals to 0. Okay, so for empirical rule, you have plus minus 1 standard deviation. And then you have minus 2 and then you have the last one is minus 3. The same thing here. This is 2 and this is 3. So according to the empirical rule, plus minus 1 standard deviation. So this area, let me use a different color. This area is actually 68%. So if you talk about plus minus 2 standard deviation, this area is 95%. If let's say plus minus 3 standard deviation, the area is 99.7%. This is what the empirical rule says. Okay, now you want to test. You want to check. You want to verify whether empirical rule is actually giving the same answers with your Z formula. Remember this just now? You compute using Z formula? Okay, so let's try to use Z formula. So for the Z formula, okay, if you compute the Z value equals to 1.00, right? So what is the probability? Then you go, if you want to convert Z value from 1 into the probability, you have to refer to the table, the Z table, right? Just now we have computed it. So Z equals to 1 is basically equals to 0.3413. So this is the probability, right? So this is the case if your Z equals to 1. But now you have two values of 1. You have negative 1 as well as a positive 1. Okay? So if let's say according to the Z rules, okay, negative 1 is 0.3413 and positive 1 is also the same, 0.3413. So you multiply these two or you plus these two, you will get equals to 68%. So basically it is the same with the empirical rule. And if you try with the 2 standard deviation, you will get the same. 3, also the same. So what does it say? It means that the empirical rule is actually consistent with your Z formula. Okay, if let's say the question asks you, can you verify the result in empirical rule with your Z formula? So you can show this working. Okay, so next, wow, let's look at the examples of your empirical rule. Okay, so remember, right? So for empirical rule, okay, you have 68%. The value is 1 standard deviation, 95. 2 standard deviation, 99.73. Okay, in empirical rule, you have a different formula. Okay, you haven't seen the formula, but now is the time for you to see the formula of empirical rule. What is the formula? Very simple. Mu plus minus K standard deviation. Okay, what is this K? Okay, the K will equals to 1 if let's say the percent is 68%. K will equals to 2 if let's say the percentage is 95%. K equals to 3 if the percentage equals to 99.7%. Okay, now you know the K because empirical rule is you only have 3 standard deviation and 3 K value. Okay, so now look at the question. Okay, I forgot to read from the beginning. So what is the information given here? Let me use different color. Okay, so it says that for a particular alkaline battery, the mean life, so the mu equals to 19 hours, standard deviation equals to 1.2. Okay, now about first question, about 68%. So you know that 68, the K equals to 1 of the battery fail between what two values? Why do the question ask you to find two values? Of course, if you look at the formula of your empirical rule, you have plus and minus. And when you talk about range, right, you will start your number from smallest to largest. You will count 1, 2, 3, and so on. You will not count 10, 9, 8, right? So you will take minus first and then plus. So let's try to apply this formula. What is your mean? Remember the formula is mu plus minus K standard deviation. The mu is 19 plus minus K. K for the first question, 68. So your K will become 1. Multiply with, what is the standard deviation given here? 1.2. Then if you apply this formula, you will get the value is between 17.8 to 20.2. Okay, this is the range. And you can also try with the 95% when the K is equals to 2. And last, you can also try, because if you look at the question, they doesn't tell you about 99.7%. They can say, because 99.7 is almost 100, right? So they can say virtually all the batteries, or they can say that almost all, or practically all the batteries. So you can tell that when, or maybe majority, okay? So you can tell that from this word, it means that it's about 99.7. Then your K will be 3, okay? Now, yes. So let's look at this question. Finding area under the normal curve. So basically, finding area under the normal curve is just asking you to find the probability. Okay, so this question basically refers to the previous one. Okay, this one. So what is the information given from the previous question? So it says that information is that, if you can see my cursor, the mean is 1000, standard deviation is 100. So let me write it down. Mu equals to 1000, and then standard deviation equals to 100. These are the information. So what is the question? Okay, what is the probability of selecting Uber driver whose income between 1000 and 1100? Okay, so you want to know the probability of the Uber driver receive between 1000. So this is your X actually. To 1, so this is 1100. Okay, so in probability, the first thing that you have to do when you read the question is list down all the information. Second, you have to draw the diagram as big as possible so that you can see which area are we talking about. So when you draw a diagram, remember the middle point is equals to 0. Okay, let me make it bigger. The middle point is equals to 0, and you know that 0 is actually in terms of the z value. You also have in terms of x value. So your x value, what is the middle? The mu. So you have to write here mu equals to 1000. Okay. Okay, so remember you have to draw the middle. For z, the value is 0. For your x, the value is your mean. Okay, which is 1000. Now, let's look at the question. What is the likelihoods of probability is between 1000 to 1100? Okay, so if you want to find the probability of 1000, right? This is 1000. So you know that the z value is 0. So you don't really have to compute for 1000. Okay, so how about 1100? If you look at your graph, 1100, is it on the left side or on the right side? Anyone? Your middle is 1000. So your 1100, is it on the left or on the right?
On the right.
Yes, thank you. So on the right, you will have, this is 1100. So you want to find this area. That's why if you draw the graph, you can see where is the area that you are interested to find. Okay, so how to find this probability? Remember, you're going to use the formula of z equals to x minus mu over sigma. So what is this x? Okay, so first, this is your first x, this is your second x. You already know the first x is that the z equals to 0. So no need to compute for the first x because it is mean. But now you have to find the second x, right? So what is the second x? 1100. So you take 1100 minus mu. What is the mu? 1000 over 100. So what do you get? When you have this working, you will get the value equals to 1 or 1.00. Remember, we have actually search for this. Z equals to 1, you will get the probability equals to 0.3413. Right? So where is it? Here. 0.3413. So this is the area you are looking for. Okay. So now, what's next? What is the likelihood? See, when they want to ask you to find the probability, they will ask what is the, let me write here. What is the probability of something? Or what is the likelihood of something? What is the chance of something? Or find the area under the normal curve. So the word area under the normal curve is also telling you about the probability. Okay? Okay, now, what is the question? What is the likelihood of selecting Uber driver who earn less than 1,100? Okay, so now, let me see what color is my pen. Okay, so now you have computed this area, right? But the question asks you to find probability of less than 1,100. So here is your 1,100, which is this part. This is 1,100. So if you want to find the area less than that, so less than 1,100 is this whole thing, right? This whole area, less than 1,100. How to find it? Okay, so you already computed the area for the green one. This one, right? You have computed here, which is 0.3413. And then now, how are you going to find this area? The non-green one. How to find this area? So remember the rules of the normal curve. The left side is 0.5, the right side is 0.5. So you will just take plus 0.5. Then you will get the answer of 0.8413. That's it. So basically, it's very important to remember the step. List down the information and then draw the diagram. And then the next part, you have to apply the formula of Z. Okay, but many students stop here. When you got the formula of Z, then you stop. But Z is not the probability. Z is just the Z value. How to find the probability? You have to refer to the Z table. Then you will get the probability. Okay? Okay. I will just keep moving unless you tell me to stop or you want to ask question. Okay? So this is just another example, right? Okay, so this is the second point, which is finding a value of your x using the Z formula. So remember, all this while, your x will be given question, right? And then you will apply the formula of Z to find the probability. Remember. But now, they don't want to give you the x. So how you want to find the x? From the probability, and then you convert into the Z value, and then you can find your x. So it's like a work backward. Okay, so let me write it here. So previously, what you're gonna do, x is given, okay, and then you use Z formula to find probability. But now they will give you probability so that you can use the Z formula to find the x. So they kind of work backward. Okay, so let's look at the example. This tire reveal the mean mile age. Remember the first step of probability? Write the information. Mu equals to 67,900. Next. The standard deviation equals to 2050. What else? So here you look at the question. Let's x represent. Remember, you have to find the x using the Z formula. Let's x represent the minimum guaranteed mile age. Okay, using the formula of Z. Okay, so now you have listed down the information, right? So the second step is that you have to draw your diagram as big as possible so that you can see it. Okay, the middle is 0. So it says the minimum. The word minimum, okay, you know that minimum, smallest, whatever, something similar word to represent minimum, it should be on the left side. But when you talk about maximum, larger value, whatever, something similar to maximum, it should be on your right side. So the minimum, it says that, which is on the left side. What is the minimum value? So the minimum value, it says 4%. So they want to make sure that not more than 4% of the tire need to be replaced. So 4% is given here? Well, since this is a probability, just change the 4% into decimal number. So 0.04. Okay, they want to make sure that the number of tire to be replaced is not more than 4%. So this is actually your X. They don't want it to be more than that. If let's say many tires need to be replaced, they will be having bankruptcy, right? So they want to be the smallest as possible. So now you know that this is the minimum and you want to find the value of your X. Okay. So they give you the probability. Remember I mentioned they will give you the probability. Okay. So now you can see that, remember, half of the diagram will give you 0.5. So you get 0.04. Can you find this area? Can you find this area? Anyone? How to find this area? You're going to take 0.5 and then minus 0.04. You will get the value of, what is it? You will get the value of 0.46. So 0.46 here, okay, normally they will give you the percentage, the minimum, the whatever value, minimum or maximum, and then you will find the remainings of the value, which is 0.46. So this is a percentage. Now your next move is to convert it into Z, because this 0.46 is your probability, right? So remember the Z formula. Okay, I'll put the Z formula later. So how to convert this probability into Z? Okay, let's go to the Z tables, right? Where is your Z table just now? Okay, it's so big. Okay, so 0.46 is the area under the curve. Remember, it is your probability. So area under the curve is this, all this inside the Z table. Okay, now find the 0.46 inside your Z table. Okay, let me see. Let's make it bigger, 0.46. Okay, where is it? 0.43, 0. This is 0. It's here. Okay, you have two close value. Remember your value is 0.46. So you're not sure. Should we take 0.4599 or 0.4608? So which one? Okay, students always make mistake here. So that's why. That's why let me take this value. The first value is 0.4599. The second value is 0. What is the value? I forgot. 4608. 4608. This 46. Yep, that's right. 4608. Okay. So sometimes you get confused. Which value should I take? So what is the rule? Take the smallest value. So remember, you want to compare with this 0.46. So how to find the smallest value? You minus with 0.46. Minus with 0.46. So the first value, what does it give you? Can someone tell me? I don't have my calculator with me. 0.4599 minus 0.46. What will you get? Anyone? 0. What? Quickly. 0.
0.0001.
How about the second one? You will get 0.
0008.
0008. Okay. So regardless whether it is positive or negative, doesn't matter. You just want to see the number. Which one is the smallest number? So you have the first one 0.001 and 008. So 1 and 8. Which number is smaller? Of course, 1 is small, right? So you pick this one. So what is the Z value for this one? Okay, let's go back to your Z table just now. So the first one, right? We pick the first one. The value is 1.7 and go up 5. 1.75. Okay, so let me write it here. Your Z equals to 1.75. Okay. Okay, so are we done? Okay, this is also another common mistake done by the students because you think that, oh, I have converted into z value. Now let's find the x. No, don't jump too quick. Why? Look at the side of your diagram. That's why drawing the diagram is very important. Your x is actually on the left side. Your diagram you are talking about on the left side. So what happened to the z value? On the left side, it should contain negative sign. Now, when you have recognized that, okay, it should be negative, I put negative, then you can apply the z formula. Still remember the z formula? That's why I mentioned to you, you have to remember z by heart. Z equals to x minus mu over sigma. You know that your z value. Okay, that's why you will take your z value to compute your x. So what is your z value just now? You get negative 1.75 equals to, you don't know what is your x. Minus your mu. Mu is here, which is 67,900 over 2050. Okay. Now this is just rearranging your values to get the x, right? Remember, I don't have calculator with me. So what you gonna do? Okay, you wanna get rid the bottom part. So 2050 multiplied with negative 1.75, what will you get? Anyone? With the calculator? Negative? Negative? What is it? You shouldn't take so long. Anyone? What will you get here?
Negative 3587.5.
Negative 358. 358?
7.5.
7.5. Okay. So you have removed the bottom part and then you will get x minus 67,900. You don't want to see this 67. You only want to see x, right? So what you gonna do? Of course, you're gonna move this 60,000 to the left side. So 60,000 is actually negative. What happened is that when you move to the left side, it will become positive. So 1,000 plus, of course, become positive, right? So you minus this 3587. What will you get? You will get the value of 64. 312 point something something. Okay, and this is your x. Okay, that's it. Okay, it's not that hard, it's just that you have to remember. First thing is what? You list down the information and then you will draw the diagram and then you will find whatever the value of z and then you will use the z formula and rearrange the formula. That's it. You will get the answer straight away. Okay. So the common mistake done by the student in this part is actually, let me use different color. Where is it? Yellow. So this part, when they have actually, they want to choose what is the z value. Okay. And they also make mistakes. Sometimes they forgot to put the negative because it is on the left side. And sometimes they don't know how to rearrange the formula to get the x. That's it. The remainings are, once you know this, you shouldn't make any problem. Okay. So next, oh yeah, I think this is the last one. Let me use a new sheet. Okay. Wow, approximate a binomial distribution. Okay, so basically, binomial is covered in previous chapter, discrete probability distribution. So why do you see this here? Okay. So, well, remember, for the discrete, all the question will be the result of counting, right? And no decimal. But for the continuous, you know that there are the result of measuring, you have decimal point. Okay. So in the discrete, because you want to count the probability, right, of one person having whatever probability of two persons and so on. So the number will be small. You will have, maybe you will compute the probability of just one thing or two things. So the number will not go more than 20 n. But sometimes the number is a lot. So it's hard for you to actually compute the probability. Okay. That's why we're going to use the Z formula under chapter 7. Okay, so let's see here. Okay, I think this diagram is better. Okay, so you can see here, we are talking about customer. So customer is not this in terms of continuous, right? You will have one customer, two customer, and so on. But the number of customer is actually a lot. If let's say the question asks you, compute the probability of having customer 43 until 68. Wow, you will have to compute one by one. It will take you forever. Okay, you can see that the number is a lot. Okay, so when the number is a lot, but you know that the number is discrete. But when the number is a lot, okay, so in statistic, we will assume that when the number is longer, it will actually go up to infinity. So it will form a normal distribution. That's why you will use normal probability distribution formula, which is Z. Okay, so you can see a lot of customers here. Okay, but if let's say this is a discrete question, customer, but then you want to use the formula of Z, what you're going to do, you have to adjust the formula using a correction factor here. Okay, how should we do? Okay, there are 4 scenarios. Okay, so the first thing is that if let's say, I hope that you should know, the first occasion or first case is if let's say at least X occur. Okay, so if let's say your X equals to 5, so it says at least X, at least 5. So the meanings of at least is the minimum, right? So you have 5, 6, 7 until maybe your number is 68 just now. Okay, the second rule, before the second rule, so if let's say you have at least X occur, what you're gonna do is, if let's say your X is 5, so you will take 5 minus 0.5. You will take minus. Okay, the second is, what is the case? More than X occur. Remember your X is 5. If let's say people said more than 5, 5 is not there because it is more than 5. So you will have 6, 7, 8 until 68. So what is the rule? What you're going to do is, you will take your X, your 5. Is it your X is 5? More than 5, right? So what you're going to do? You will take your X, which is 5 just now. You minus with 0.5. Okay. So what's next? So the third scenario is that X or fewer. So X or fewer or less. I will say less. Okay. So what is your X just now? Your X is 5, right? So X or less. So you have 5, 4, 3 until whatever the value is. In this case, the rule is your X should plus 0.5. And the last one, well, somehow you have to remember this as well by heart because you're gonna apply it in the question. Fewer than X. So this is fewer than your X. So your X is 5, right? So fewer than X, 5 is not there because it is fewer than 5. So 4, 3, 2, and so on. So in this case, what you're gonna do, you will have to take X minus 0.5. That's it. So these are the, I can say the rules. Okay, now let's look at the example. I want to make it bigger so that you can see it clearly. Okay, so use different color. This one. Okay, suppose okay, whatever it is, you are given 70% of its new customer return for another meal. Okay, whatever. So basically, remember in the continuous probability distribution, you will be given what? You will be given mu and sigma to apply the formula of z. But now you are given the pi. Remember, 70% is a percentage. You are given the pi. So when you read this question, you may think, well, they are not giving me the mu and they are not giving me the standard deviation. They are giving me the pi. So list down the information. Okay, pi equals to 0.7. Or you might be thinking, maybe this is about chapter 6. Okay, and then when you look at the variable, we are talking about customer. Customer is the examples of discrete. Okay, now you know that this is discrete. Okay, and then if let's say you are talking about continuous, maybe they will talk about what is it? Salary. So all the value will have decimal point. So for a week in which 80 new customer, 80 people, this is a lot, right? So your n equals to 80. Oh, the moment that you see this is more than 20. No, this, even though this is discrete, but it fall under chapter 7. So this is approximate to binomial. It is binomial formula, but then you have to also integrate with your z formula, because this is a lot. So you can have a normal distribution. Okay, so now what is the probability that 60 or more will return for whatever? So 60 or more. Remember the case? Whenever you have approximate to binomial, so you have 4 cases. Okay, what is the probability? Probability of x is actually equals to 60 or more. So where is the 60 or more? So means that you have 60, 61, blah, blah, blah. So this is the examples of at least x equals to 5. You have 5, 6, 7, and so on. So your 60, okay, let me write here, your x equals to 60. Your 60 will minus 0.5. What happened to your 60? It's become 59.5. So your x value now has changed. It's no longer 60, it's become 59.5. Remember that. Okay, that is one thing. Okay, so next. Hey, where is my cursor? Okay, next. Okay. So you know that this is approximate to binomial. You want to use the formula of your z. Okay, but well, let me rewrite the z formula. Z equals to x minus mu over standard deviation. Oh no, you have to find, well, you know that your x here, right? It has been changed into this one. Okay, you have your x. But how to find the mu? They didn't give you the mu. Remember the formula in chapter 6 for mu? Mu, let me write it somewhere here. Mu equals to n multiplied with probability, or what we call pi. Okay, so what is your n? N is 80 multiplied with the pi 0.7, you will get the value of 56. Okay, now you have your mu. You have to also find your sigma or your standard deviation. Okay, so you will just use the formula for variance first in your previous chapter. That's why approximate to binomial, you have some formula from binomial, and then you also have to apply the formula of z. Okay, and you use the formula of variance, and then put a square root, you will get the sigma equals to 4.10. Okay, so let's assume that you know that your sigma here is actually 4.10. Okay, so what's next? Just apply the formula. Your x become 59.5. Mu will be, let me write it here, make it bigger. Oh, that's the max. Mu will be minus 56 over, what is your sigma? 4.10. Okay, remember, the first thing that you have done is actually you list all the information. This is the first thing, right? You have listed down all the information. Okay, so you also have to what? You also have to draw the diagram to see which area are we talking about, right? So this is my diagram. Okay, so 0. So what is the middle? Your mu value, right? So your mu is 56. So the question asks about okay, 60 or more. Remember your 60 now become 59.5. So 59.5 or more. So where is it? 59. So 59 will be maybe, okay, this is your 59.5 or more. Okay, so you want to find 59.5 or more. So this area. So how would you do that? Okay, so, well, basically you have to compute the formula, right? 59.5 minus, so basically it is the green area. So you have to find this probability first. Okay, in order for you to find 59.5 or more. So how to find it? So you take the x, which is 59.5, minus your mu here, right? And then over standard deviation, you will get the value of, what is it? You will get the value of this one. Okay, let me write it here. You will get the value of 0.85. But this is just the z value. Remember, you shouldn't stop here. You have to refer to the z table. Okay, I assume that you know how to look at the z table. And then you find 0.3023. Okay, so you already got the value here, which is 0.3023. So how to find this green area? Anyone? You will take, remember, half of the diagram will give you 0.5. You will take 0.5 minus the one that you have computed, 0.3023. So you should get the value of, what is the value? I don't remember. 1977. You will get 0.1977. Okay, so which part that students always make mistake? Okay, let me highlight it. Students always forgot to convert the 60 into 59, applying the 4 cases. Okay, and sometimes student when they look at this the pi, they didn't think that this is approximate to binomial. They will just simply apply the formula of binomial. So this is another mistake. Okay, and yeah, I think that is the common mistake done by the student. That's it. Okay, so any questions so far? Any question? So I think we have covered everything. Unless you ask me question, then I will stop. Okay, so now I have covered the materials, although I already asked you to watch it in advance, but still I will discuss in class. So now let's look at the question. I mean your exercise. Okay, I'll open the textbook as well. Okay, so this is your exercise. Remember, this is just the sample. You have plenty of questions from the textbook. Page 268, 15. 268 is 8, right? 268, 15. What did I write? 268, 15. Okay, now. Okay, let me open a new blank sheet. Okay, 15, right? So what do we have? Okay, a recent study of hourly wages. So you can see that the variable is wages. So this should tell you, it should give you a hint. Well, we are not talking about discrete because wages is like your salary. You can have like your salary 1,550 cents. You can have that, right? Okay, so wages is actually the examples of continuous. And then you can also see the number is in decimal point. So now the first step, list down all the information. So mu equals to 20.5, standard deviation equals to, what is your standard deviation? 3.5. 3.5. Okay. Then if you select a crew member at random, what is the probability? Remember, X is given in the question. What is the probability the crew member earns between 20.5 to 24? List down the information, the first step. Second step, don't forget your nice curve. Okay, the middle is 0. This is your Z. How about the X? The X is your mu. Okay, 20.5. So the question want to know the probability of your x is actually between 20.5 to 24. Okay, so where is it? So 20 is in the middle, right? So you don't really have to compute your first x. You have x1 here and then x2. Your x1, if you want to compute it, you will get the z equals to 0. You don't need that. Okay, so 24. So maybe 24 is somewhere here. This is your 24. So you want to know the distribution or the probability is between this area. So how to find it? Of course, the next one. So the first step, remember, list down all the information. Second step, draw the diagram. Third step, apply the formula of z. So what is the z formula just now? Z equals to x minus mu. Okay, by now you should remember the formula already, divided with sigma. So what is your x? What is your x?
24.
Yes, your x is 24 minus your mu given from the question. You have 20.5 sigma
20.5.
also from the question. Okay, so can you help me to find this? 24 minus 20.5 divided with 3.5. What will you get? Anyone?
1.
1. Thank you. So you know that. Well, if you don't know, you can just refer to the diagram, to the z tables, right? This one is not final. This is just your z value, right? So you have to convert by looking at your z table. You will get 0.3413. So yeah, this is the probability of 0.3413. You got the first answer. Second, more than 24 per hours. This is just like your exercise. your slide. So where is this more than 24? So this is your 24. Okay, or this is your 24. More than that is this area. So to find it, of course, you will take 0.5 to represent half of this diagram. So 0.5 minus the one that you have computed here, which is 0.3413. So you should get the answer. What is the answer here? When you minus it, you will get
0.1587.
okay. I hope this answer should be correct. And the same thing with less than 19. So less than 19. So you know that your middle is 20, right? So 19 should be here. Okay, 19 should be here. So you find the probability for 19 first. Okay. And then once you get the answer, where this is the probability that you will get, and then the answer you minus with this. Okay, because less than 19 is this part. So the same thing. Okay, so basically you draw a diagram, then you find out where is the area we are talking about. Okay, so next next is page 270, question 21. 270, question 21. Where is the 21? 21. It's here. I think this is the same thing. Let me have a look. Let's open a new sheet. Okay. What is it? This station, find the probability, blah, blah. The mean distributions of the mean distribution, the mu is 15 and standard deviation is 3.5. What is the probability that particular listener will tune in more than 20 minutes or less and between? So basically the same example. Okay, I will just skip this example. The same. If you can do question number 15 before, and 15 is also exactly similar with our slide, so you should be able to answer this question. Okay, I just give you extra exercise. Okay, so let's look at the next one. This is 270. Let's look at 272, question 25. 272, question 25. Where is it? 25. This is another example from different point. Okay, so you have seen how to apply the z formula. Now is the examples of how to find the x using your z formula. Okay. assume the mean hourly cost, blah, blah, blah. So they mention follow normal distribution. So you know that your diagram should be normal, right? With the mean, let me list down first. Your mu equals to 2,100 per hour. Standard deviation equals to 250. What else? What is the operating cost for the lowest? 3%. So the word lowest, this is like your minimum, your smallest, right? So you should know how does it look like. So you draw a diagram, don't forget your diagram. It will help you a lot. Middle, put 0. So they tell you the lowest is 3%. This is the lowest, which is 3%. Very similar to your exercise. So convert it into a decimal, 0.03. So they want to know what is the lowest value, which is this one. And the lowest value is your x, right? So can you find this area when you already know that the shaded area is 0.03? What is your what the area here? Can someone help me to find? You have to take 0.5 minus 0.03. What will you get? 0.
0.47.
0.47. Is that correct?
Yes.
Okay. So I'll write it here, 0.47. So remember, what is the 0.47? This is your probability, right? So you want to change your probability into z value. Remember how does it work? They will give you the probability, okay? And then you will change it into z value. From the z, you will find your x. Okay, so this is 0.47. It is area under the curve. So I'm finding my cursor. So 0.47. Right. Okay. This is 0.47, but this is too large. Where is it? 0.47. You have two closest value here. Now is your task. Let me scroll up a bit so that I can, okay, up. Okay. You have 0.4699 and 0.4706. Which one is the closest? Okay, remember, students always make mistake on this. A. Where is our value just now? Okay, here. Okay, so you have two value. Value number 1, which is for I want to put 0. 0.4699, and number 2, 0.4706. Okay, so how to find which one is the smallest? Remember, you have to minus with 0.47. Okay, so tell me, the first one will give you what value? Because I don't have my calculator. So for the first one, you take 0.4699 minus 0.47. What will you get? Anyone? 0.
0.0001.
0.00. You have 000.
0110.
I mean, the 0 here is 3 or 2.
1.
Can you say 0.
0.440, I think.
Can you say what is the answer? 0. Can you just read the answer again? 0.
0.0001.
Okay, that's good. And the second one? 0.
0.0006.
So you have 0.0006. Is it?
Yes.
Okay. So everyone, make sure that you have your calculator with you so that you can double check the answer given by your friends. Okay, so you can see here, regardless of the sign, negative or positive, 1 is actually smaller than 6, right? So which one will you choose? Of course, the smallest gaps. Okay, so what is the smallest gap? What is the z value? So the smallest, you choose the first number, right? Let me write it here. Where is it? 0. 47, right? When you make it bigger, then you lost the number. This one. So you choose the first number. So the value of z equals to 1.8. Is it 1.8? Yeah, 1.88. Okay, right? Okay, given that your working should be correct, so your z value equals to 1.88. So don't proceed with applying the formula. Check first. Is it on the left side or on the right side? Okay, is the lowest right? So your z value should contain negative. Don't forget that. Now, you can proceed with the z formula. What is the z formula? Z equals to x minus mu over sigma. Your z here is negative 1.88 equals to, you don't know your x at the moment, minus your mu, 2100. Is that how 2100 look like? Let me, 2100. What happened to my handwriting? 2100 and then divided with sigma 250. Okay, the same thing, you have to rearrange the value, right? How to rearrange? You take 250, multiply with this, and after you multiply with this, so 2100, you plus with this answer. So can someone tell me the final answer? Anyone?
1630.
1630. Okay, please double check the answer. Hopefully this is correct. Okay, so yep. I think this, yeah, it is done. You have found your x. Okay, so let's move to the next one. You still have plenty of time. Okay, question number, page number 277, 35. 277, 35. This is 34, 35. This one. What is it about? This is another example. Okay, I already run out of the blank sheet. Let me write a new one. Pen thing. Okay. Okay, so now a study conducted by this health club revealed that 30%. So whenever you see 30%, you might think, well, this could be chapter 6, discrete, right? They give you pi. Let me write it here first because you never know. So pi equals to 0.3. But then 30% of its new member, okay, are significantly overweight. Well, you are talking about member. Member is what? New member. Member is a person, right? So you are saying that 30% of the new member are significantly overweight. So when you talk about a person, okay, this is binomial, right? You count the person. This is discrete number. Okay, so you think that you have the pi, you have the discrete variable. Okay, this could be chapter 6. Okay, let's continue. A membership drive in a metropolitan area resulted 500 new member. Okay, so you have your n is 500. Well, if you look at this 500, I mean the n, 500, this is too big. Of course, it is more than 20. Now you know, even though it is talking about discrete variable, but the number is too big, you have to apply approximate to binomial. Okay, so all the question, the statement will give you a clue. Which formula should we use? Okay, that's why sometimes, especially in the final exam, you are given comprehensive of question from chapter 1 until chapter 15. Okay, so you have to know, the formula will be given. You have to know which formula should be used. That's why when we discuss the question, I will tell you, this is the clue, this is the keyword, so that you know. Okay, so now that you know that the number is too big, you are given the pi. Well, this is approximate to binomial. Okay, it has been suggested that normal approximation, this is the question from your textbook. Of course, they will tell you we are talking about normal approximation, but in the final exam, they will drop this. Okay, they will just simply ask you, okay, well, I forgot. They haven't, the probability is in number B. Okay, Okay, but here they just want you to explain, right? Does this problem qualify as a binomial problem? So you know binomial has a, what we call? They have a requirement. I mean criteria if you want to apply for binomial. Hey, why is so long? It took some times. Okay, okay. Let me see binomial, right? This is probability. I want to go to binomial. Where is binomial? Binomial. This is your binomial. You have 4 criteria. There are only 2 possible outcomes, right? So let me look at the question. You should only mention 2 outcomes. Where is it? Conducted by this percent new member are significantly overweight. So whether your new member are overweight or not overweight. So you have 2 outcomes. Either they are overweight or not overweight. Okay. Okay, then this is the first criteria. Means that they are either overweight or not overweight. They cannot be in the middle. The number of trial is fixed and known. So basically, in this case, you know that they didn't mention to you, well, of course, where is it? Okay. Okay, your number is already given, 500, right? So you should know how many people are we talking about, right? And then what else? So it also tell you that we are talking about the number of people. So this is discrete. It is not continuous. You know the number. Okay, what else? So basically you have to list down this criteria, this requirement to tell you that you can use binomial formula. The probability of success is the same. What is the probability of success? They give it to you, right? What is the probability of success? Your pi is 30%. Let me put it side by side. I keep looking at the slide, and okay, done. Number 4, each trial is independent of any other trial. Of course, right? The pi will be independent. Okay, that's it. Mention that. Explain. Basically, you just mention the requirements of binomial. Okay. Next, what is the probability that 175 or more new members are significantly overweight? You have listed down the information. What's next? Next is, of course, don't forget to draw your diagram. Well, doesn't matter. As big as possible, right? Okay. So this is 0. I want to make a straight line, but somehow I don't know what happened. So this is 0. So the middle should be your mean value, but you don't know the mean, right? What you gonna do? Find the formula of mean. How to find the mean? Mu equals to pi minus multiply with n. Okay, so you will get 0.3 multiply with 500. What will you get? Anyone? Anyone? Have you done the exercise?
150.
150. So basically your middle is 150. Okay, I hope that this is correct. Okay. What's next? What is the question just now? What is the probability 175 or more, right? Okay. So let me just write down the question. Probability of x equals to 175 or more. Okay, you don't really have to worry the statistical way of writing it, but this is just telling you x is actually equals to 175 or more. So 175 or more, where is it? It should be somewhere, because the middle is 150. That's why it's very important to draw the middle line. 150, so 175 is somewhere here or more. You want to find this area. But before finding this green area, you have to find this value first. So how to do it? Of course, you have to apply the formula of z equals to x minus mu over sigma, right? Your x is clearly mentioned. It is equals to 175 minus your mu. Where is the mu just now? Mu is here, 150 over your sigma. So basically here you also have to find the sigma. Can someone tell me what is the value for your sigma? Assuming that you have applied the formula, what will you get for your sigma? Anyone? What is the sigma?
10.25.
10.25. Wow, okay. So let me put here the sigma is actually 10.25. Applying this formula, what is your z value? What is the z value? Anyone? Remember, I don't have my calculator. If you want to finish early, give me the answer straight away. What is it?
2.44.
2.44. Let me assume that this is correct. So if you refer to the z table, what is the answer? Or you haven't seen the z table yet? Because z table is here, right? So where is this 2.44? 2.4, and then the 4 just now is where? Is here. Is here. Is here. Let me make it smaller. Where is the 2.44? This is 4. This is 2.4, and then 4. 0.4927. 0.4927. You will get 0.4927. Okay, so the probability that you have found here is actually from your x, 175 to 150. So from 175, which is this one, to 150. This is the probability that you have found, right? If you look at the formula, x minus mu, so your x is 175 minus 150, 175 minus 150. So this is the area, which is 0.4927. Okay. Right, 2.4. Let me double check 2.4. 2.4 and then 49. Okay, that's right. Okay, now this is not the answer yet because the question asks you more than 175. Well, what is this? See what's the problem that I made? I just realized. What is the problem? Anyone? Can you see the problem? We haven't adjusted for the 4 cases. That's why this question is a bit tricky because you know that we are talking about large value. So your x is actually, luckily I remember this. Your x should be adjusted. Your x, where is the x just now? Probability of blah, blah, blah. Where is my probability? This one. So your x shouldn't be 175. You have to adjust it because you want to use the formula of approximate to binomial. So 175 or more. Okay, or more. So this is like at least 175 or more. So if let's say the case of at least, where is the scenario just now I mentioned? Where is the case of at least? So at least you have to minus with 0.5. So you shouldn't make this mistake. I've done it somehow, but later on I realized. So you take this 175 minus 0.5. You will get the value of 17. What is it? 175 minus 0.5? Is it 174.5?
174.5.
Yes, 0.5. So this is your x value. So you have to change this 175 into 174.5. Okay, because although the area is the same, but then when you want to apply this here, you will get different answer, right? So please change this 175 into 174.5. Then you will get a different z value and you will also get a different probability value. Okay, can someone help me to fix this? If let's say you change 175 into 174.5, what will you get for the z value? Use your calculator right now.
2.39.
3 point?
2.39.
Okay, let me adjust this. 2.39, right? 2.39. And then this is just the z value, change it into into the probability 2.39, right? 2.3, where is it? This is 2.3. 9 is 9. Okay, 2.3, 9 is at the end. Okay, so the value is 0.4916, right? 0.4916. So we'll put here 0.4916. Luckily we have solved it. So this is 0.4916. That's why in probability we always ask you to give 4 decimal point. Why? If you use 2 decimal point, you will also still get 0.49. But when you have 4, then you will see, oh no, they are actually different. That's why we need 4 decimal point. This is 0.4916. It is very important. You have to give in terms of 4 decimal point, because those 2 decimal point, you may actually make mistake, okay? But they are different. Okay, so you have 0.4916. So what you're gonna do? So this is just this area. You want to find the green one. So you will take 0.5 minus 0.4916. What will you get? What will you get? 0.
0.0084.
0.0084. Okay. So remember, basically the red color is telling us that, well, this is the correction made, because I forgot to adjust the X, the 175. So remember, it is very common that you, once you already computed the mu, the standard deviation, you simply apply the Z formula. But you forgot, we are talking about different, approximate to binomial. So please adjust the X according to 4 condition. Okay. Now you have realized it. It's luckily that I did the mistake, so that you can see this is very common. You know how to do it, but sometimes you forgot. Okay. So, well, I think that is the last question, right? 27735. Yes. So let me end the recording first, so that